Hey, happy Monday.
Happy Monday. How's it going?
Good. How was your weekend?
It was good. It was restful. Got a little bit of work done, but managed to take some long hikes and along the bench. Yeah.
Nice.
Yeah, you got to enjoy the good weather while you have it. That is, when I say good weather, I mean no smog, like and
Right.
low temperatures.
Yeah. So for people listening, Salt Lake Valley, where we live, it tends to get what's called inversion during the winter. So the cold air kind of sinks at the bottom of the valley, and it's actually warmer on top. So it traps all the pollutants down in the
Yeah,
valley, sometimes for weeks on end. So
it's not good. So I like it when it's like this, nice and clear.
yeah, it was perfect. Yeah, I went hiking up West Granger yesterday as well, and that was fun. So looking forward to more days like that this week, and hopefully we can get out. So cool. I think this week we wanted to talk about something I think you have much more of an area of expertise than I do, and that's uh, advice for people moving from maybe an academic position um, into data science. So this is a question that comes up quite a bit on LinkedIn and social media, as well as various Slack groups. People may be professors at an existing university doing research, postdoc research, or whatever. Or I guess we could also say like somebody who's coming from maybe an academic background, maybe they got a PhD and haven't had any work experience. So I don't know
Right.
how you want to talk about it, but I'll let you.
Yeah. And I'll say that this is advice is broadly for people with a really strong academic background in something that's very heavy in math and or stats. Probably not advice that appeals to people as much on more of a conventional data science track with like a PhD in computer science or something like that. There you have a much more defined career track. But I would say that the people I'm speaking to are those who are simultaneously overqualified and underqualified. So by that, I mean that they might have a PhD in chemistry. They know a lot of math because they've done tons of physical chemistry. They are very good at stats, but they maybe have done some R, some MATLAB. They don't know Python necessarily super well, or they don't know the specifics of data science or business environment. So yeah, that's kind of the audience I intend here. And I mean, frankly, that was basically my background. I finished a PhD in math in representation theory, which is an area of pure math, not super statistical. And then I did a postdoc, and then I taught for several years after that. And that's when I started to get into data science and data engineering. And I find that people have all these qualifications that they're kind of at sea in terms of deciding how to actually get into the profession. And so that's the advice I wanted to get.
Interesting. So, I mean, let's step back and when you were doing uh, when you're definitely more in the academic realm, like what got you interested in data science in the first place?
To be honest, one of my other friends, we started our PhDs at the same time at the University of Utah, and we also worked on research together. And he was a data scientist at Overstock, and he basically said, "Hey, look, if you should consider getting into this field. I think you enjoy teaching, but there are opportunities here too if you ever decide you want to go in a different direction." So yeah, in my case, someone really reached out to me and encouraged me, but I kind of want to do the same thing for other people, just to let them know, whatever you're doing, there are other opportunities depending on what your interests are and where you want to take your career in the future.
Interesting. So, what's some of your advice?
So first bit of advice, and don't take this the wrong way, but um, academics tend to be very oriented toward formal education, which makes a lot of sense. I think if you have a degree that uses a lot of math, like a master's degree or a PhD, then a 2 years master's in data science might not actually be that valuable for you. Um, in particular, I think you'd be better off focusing on your own learning with the skills you have, plus just trying to get your first job somewhere, even at the very bottom of the pay scale. I think you're going to learn a lot faster that way. I also think that those programs tend to target people maybe with not, you probably have more math and stat skills than a typical entrant into one of those programs. And so that's why you might end up spinning your wheels a bit. I think you can learn a lot faster on your own because you bring these very strong mathematical skills into the mix starting out. Now, when I say on your own, I'll loop back to that in a second. I don't think you should truly be trying to learn all this on your own. You need guidance, but you can still be an autodidact with some coaching.
I mean, are there specific areas where somebody with a technical background and with a formal education may want to focus on more than others with respect to a career in data science?
Yeah, that's a good question. And I'll want to solicit your advice on this too, because you built teams and you kind of have a sense of what's going on out there. I think we both have a sense of what's very useful in the business world, but maybe a slightly different sense. Um, it's funny when I'll loop back to something we talk about again and again. One of the most fundamental skills you can gain, which frankly many working data science practitioners are pretty weak in, is SQL. Just the very basic lingua franca of accessing and transforming data. Just get good at SQL because that right away will differentiate you from a lot of other candidates, and in conjunction with your other skills, allow you to start doing things with data almost immediately.
Yeah, I would say SQL, that's a good one. It's kind of an interesting one to start with because it's not a traditional programming language.
Right?
And unless you had a reason to use SQL, um, like a job, it's
People
going to
learn
be
it on the
really,
job, right? Yeah, they don't
yeah.
learn it at school typically,
No,
except
I know. It's, I mean,
for
we're teaching a class in SQL, and I would say that the students who come into that, they tend to do a good job. But a lot of them have had, prior experience, typically through a prior job doing it. But if you're coming from a formal academic position, I'm just trying to think of like when you would use SQL. I could see a situation where you would more be prone to use R or Python or SAS or MATLAB or Maple or any of the other languages that you'd use kind of more in an academic setting. But
yeah. Well, the funny thing is, I think would be extremely useful for many academics. So I think
yeah,
academics, maybe in the business schools, especially if they're straddling IT and business, like we have at the Eccles School at the University of Utah, tend to know some SQL. But if you're in a math department or a stats department, it's extremely unlikely that you know any SQL, which is too bad because in the modern data environment, SQL gives you access to all kinds of open data sets, paid data sets, and just a whole constellation of things that might be interesting for your research. So in
yeah,
particular, I'm thinking about Snowflake and BigQuery both offer a bunch of public data sets where you can basically sign on, create an account, and then you just pay for your usage. So whatever queries you run, you pay for, but you can access this open data very quickly, start transforming it, filtering it, what have you.
yeah. I mean, so that's the skills to get data out of a database or data warehouse. But then what would be some skills for doing things like machine learning or anything related to that?
Yeah, so I think we probably both agree that Python is kind of just table stakes. It, the other benefit to Python is that if you haven't done a lot of programming, it's a really great segue into almost any modern programming language because you sort of learn object oriented programming without even knowing it. At first, you're not using formal methods and things, but secretly, Python is all built around objects. And then pretty soon, as you get into more advanced packages and things, you explicitly see the nature of object-oriented programming. And so my experience was I started out in Python. I actually did a lot of Python during my PhD, mostly for pedagogical purposes. So as part of teaching summer high school programs we had where we teach high school students about number theory, we use Python for all of that. And so I was fortunate in my case that I could level up fairly quickly to get closer to a professional level of Python. But even if you've never seen Python before, there are so many online resources for learning it. You can start from ground zero and just build up very quickly. And then once you have that skill, moving to Java, for example, becomes way, way easier. Yeah, Java is much more awkward to program in. It's explicitly typed. Um, but at the same time, those core object oriented concepts, classes and such, and methods, you'll get those in your head. And then it's not such a terrible transition to make. So yeah, as a programming language, Python is a great start. Um, R, probably a lot of people would say R as well. R tends to be pretty domain specific. And by that, I mean that some companies really love R and other places it's hardly used. But I think it's just really, it's like knowing a couple of different languages,
Hmm.
human languages, right? It's just useful to know Python and R because it gives you access right away to a lot of different opportunities.
Yeah, I would say like for languages, if you're coming into it pretty cold and not familiar with the popular data science languages, namely R, Python, um, pick one of those. I
Right.
wouldn't say try and learn both at the same time. That's a recipe for getting extremely confused and overloaded. Um, uh, you know, And my bias is towards Python. That's because I also run a meetup about Python and I've been using it forever. But
Well, it's
that
broader
said,
too.
I like R a lot because
Yeah.
I think of it more as a hand calculator.
Yeah.
The fact you can fire up R and just start doing kind of whatever you need to do out of the box is pretty cool. But that said, as the old saying goes, fish where the fish are. And even though R is seeing a resurgence recently, there's still, I would say, a lot more mind share and marketability with Python.
Yeah.
So,
Python just has such massive mind share across many, many domains, not just data science and statistics. So if I were to pick one to start, I agree with you. Like start with Python and then maybe get into R afterwards.
yeah, and I mean, that's a programming language, but then we're talking about, a
Right.
data scientist is typically going to be expected to know machine learning and possibly, I wouldn't say possibly, I would say very probably a lot of the popular
Yeah.
libraries out there. We're talking if you're talking classical methods in Python, sklearn.
Right.
If you're talking deep learning, PyTorch, TensorFlow. PyTorch is definitely more suited uh, for academic researchers, and I say that just because that's where a lot of the popularity has been with PyTorch, and now you're seeing, I would say, a growing popularity in industry with PyTorch as well, just because academics are getting jobs in industry and bringing along the tools that they like to use. So,
Yeah. And it's funny. I mean, this kind of loops back to a question we had on what is it called? The data science happy hour that we did on Friday. And someone was asking, I've learned these frameworks. What should I learn next? And that's where the advice becomes a little more complicated. You want to have the table stakes things like Python, for example, probably pandas. And then the reality after that is that the tools you use will vary so much by the job you have. So, for example, if you got a machine learning job at Google, you might spend your entire day just working in TensorFlow. If you ended up at Facebook, well, Facebook created PyTorch, so you might end up using a huge amount of PyTorch there. And so I would kind of advise like get the basic stuff down and then just decide what you're interested in. And I would also, this is where it's important to have a coach because a lot of things we're interested in might or might not be that useful. And so you want to ask around and find
yeah,
out what will help you to get a job. So combine what's going to get you a job with what you actually want to be doing based on what's interesting to you, and then focus on various essentially learning and research areas going forward from there.
makes a lot of sense. I would also say too, like there's frameworks will come and go. So the things that we just mentioned, sklearn, PyTorch, TensorFlow, in several years' time, who's to say what's going to take their place? I'm sure something will become more popular than these libraries. That's the name of the game. So, if I were to take a step back and offer advice too, it's um, learn the underlying principles
Mhm.
of machine learning and the various approaches to machine learning um, and statistical approaches if you're not familiar with stats and kind of brush up on just the fundamentals because those things aren't going to change as much. I mean, if you look at the history of machine learning, there are very few things that are absolutely novel and brand new uh, that have come out even in the last 10 years. A lot of it's built upon a foundation that was laid decades ago, sometimes hundreds of years ago. And so, if you have a good appreciation for the fundamentals, which if you're coming from a formal background um, that is very math heavy, for example, you'll have an amazing background to figure this stuff out. I would even say to having just had an undergrad in math, like being able to figure out machine learning and deep learning wasn't hard at all. And that's me. And you're probably well more qualified to, from a mathematical background to figure these things out. So I would say that, if a guy may can figure it out, I'm pretty sure you can too. So
Yeah, yeah, that's just it. And the reality too is that some things you can figure out might or might not be interesting. So maybe sample a couple of things out there with some guidance from a coach and say, well, statistics, I'm not super excited about. Deep learning, I am excited about. Maybe focus on that for a while. But going back to what you were just saying about all these different domain areas, another thing we should address is what's really hot right now versus having a broad knowledge that's going to be useful for the next 10 years. And one of the hottest things right now is still deep learning, right? I mean, everyone is fixated on deep learning. I think we both kind of have the sense at the moment that that's not going to last forever. I think at some point, deep learning will shift to being more infrastructure and not the latest cool thing. And that we'll probably need to combine it with some other techniques somehow in ways we haven't yet figured out to make it even more useful than it is. So, pick some hot things to study, but also get a broad knowledge of a number of different types of algorithms, including classical machine learning, like you said.
Yeah, I would say too that the nature of the field is also changing before our very eyes. Whereas, in the mid 2010s,
Yeah.
machine learning and uh, deep learning were a big focus, right? Because people wanted to know how to train models and make models and so forth. That is very much becoming a solved problem. I would say there's still a lot of room for people who want to be machine learning and AI researchers
Mhm.
to continue the advancement of algorithms. Um, but increasingly, what we're seeing is, I think the role of a data scientist is going to be changing quite a bit too, where it's going to be much more about gaining domain expertise and applying your rigorous formal background along with domain expertise to solving problems within industry or an organization or whatever. But it's not so much anymore about the training of models. I think that's as important as it is applying that knowledge to solving problems. And you may be wondering what's the difference between the two. Well, training a model is training a model, but training a model that yields business value and deploying that in an environment where business can continue to get value is that's a separate discussion and a much bigger area of focus that I think until recently was a bit ignored, but now is it's definitely coming into the limelight. We're seeing things like machine learning operations becoming more
Yeah,
and more prevalent. Machine
completely
learning
agree.
engineer is a new field, and so increasingly you're going to start seeing, well, now that we're able to, it's sort of in software engineering where like now that you're able to write code, how do we make this successful in production?
Right.
So just keep that
Yeah.
in mind as you're going down your data science journey is that the things that you may have read on the internet, even until a year or two ago, that whole reality is changing right now.
Right. Right. Another thing I would bring up, and this is one of our favorite topics to talk about again and again and again, is that instead of looking just at data science, you might also be interested in data engineering. And I would call data engineering a hybrid of traditional software development with data science. It kind of sits between the two. And one nice thing about data engineering, well, a couple of nice things actually, it's easier to get into because there's huge demand and there's less of a formal pipeline like there is with data science. And second, it gives you kind of this purview over a couple of different opportunities from data engineering. You can stay in data engineering, you can move into software development, you can move into infrastructure, or you can move into data science. Like it gives you this huge portal into all these other possible career options, and it familiarizes you with the entire space. It's going to help you to get good at software development, which applies to almost everything.
What's the difference between data engineering and machine learning engineering?
And I think there's a lot of overlap there too, right? And machine learning engineers can be people who work on the deep details of deep learning and neural networks, or they can be people who work on the orchestration aspect of machine learning and making sure that models actually get delivered once someone has developed the model and that model training becomes completely automated on a cadence. So yeah, that is one headache here. Some of these job titles are actually pretty ill-defined at the moment. But yeah, I would say ML engineering is maybe a little more toward the data science side, but still overlaps well into the data engineering space. So what's kind of your take on that?
I think so. If you're to draw like a Venn diagram of, data engineering, machine learning engineering, data science, I think it's sort of, that intersection of those. It's not quite traditional data engineering, like whatever that means anymore. And it's not quite traditional data science, whatever that means anymore. But I think it is somebody who's competent in machine learning who can make machine learning work in production, but is also competent in engineering principles to make sure that things are deployed correctly and engineered correctly and will work in production. So,
Yeah.
I mean, our partners over at Google Cloud, I mean, they have two certs right now, data engineering and machine learning engineer, right? And so, I mean, they've managed to figure it out. But, um, in looking at those, I would say the machine learning engineer is the emphasis on that is definitely being good at machine learning as well as being good at data engineering. So that's
Yeah,
kind of where the intersection lies. But again, these still early days. I mean, these are all made up titles that
they are.
10 years ago didn't even exist. So machine
Well,
learning engineer now may not. I don't know what that is in 5 years.
well, I mean, do you think has the term data engineer existed for a while? But if it has, I feel like it's evolved a lot. I mean, to be quite frank, it used to be like someone who would maybe babysit a big Oracle data warehouse. And now you might touch a traditional data warehouse system, but you're going to do a lot of other things too. It's this field with a very broad view of all kinds of different infrastructure systems that serves the needs, data needs of the company and perhaps of a specific data science team.
I see job titles for data engineer, and it's I think like data science tends to be this honeypot of all terms that somebody would Google for, right?
Right.
Data engineering is quickly becoming like that. It encompasses a role that maybe a DBA used to do, or an ETL developer used to do, plus sprinkling in like machine learning. And I don't know if the company's actually doing machine learning or if they're just doing that as a honeypot to get candidates or something. But so
Right.
the job descriptions just tend to sort of encompass everything these days. So I don't know. I mean, it used to be a big data engineer before, and maybe they just got rid of the big and kept the data in the title. So,
Essay.
but
Yeah.
yeah, it's hard to say. But I would say again for candidates that are still in the academic space looking to get into the data field, um, just understand like the field's changing right now, and as you pointed out, Matt. I mean, there's other ways to go besides being a data scientist. Um, I, for one, would encourage people to look at these other options because I think the field of data science is changing rapidly before our very eyes, and I'm not sure where it shakes out. I kind of think that there's three roles that may fall into, and and I've chatted about this with some other friends. And I think this is the consensus we've come to at least. It's like you're going to have algorithms researcher, that's one. A domain specific data scientist who's maybe more trying to solve business problems, maybe not training models as much. That also includes the four-letter word of data analyst. I think you're going to be a good data analyst to be an effective data scientist. And then there's also the people, ML engineers, data engineers who are going to behind the scenes help data scientists succeed in production. So at least it's how I see it going, but who
And
knows?
I think part of the thing you need to do, you really need to research these career paths. And that's a very hard problem, unfortunately, because they're not well defined. But I would say maybe break out of some of the semantics, data
Yeah.
engineer versus ML engineer versus data scientist. Find someone who's been successful, whom you admire, and go talk to them and find out what they do every day. And find a bunch of people and talk to them and find out what they're up to. And you may find that a lot of people called data engineers are actually mostly doing data science problems, training models, making high level decisions about where business value is. And a lot of people called data scientists, frankly, are mostly doing data engineering, cleaning data, and just applying business logic and rules, which is also very valuable. But yeah, just find out what people are up to. People like to talk about themselves, as it turns out. So it used to be the trick was to just buy them coffee, right? Most people like coffee or lunch or something like this. That's a little bit harder right now. But still, I mean, if you can find someone who's willing to tell you about their day to day and give you advice, that's a really great place to start. And just find out what people
Mhm.
are up to, and then you can try to steer your career in a direction that makes sense for you, that sounds interesting and enjoyable.
I think to kind of switch gears too, there's also the question of I'm about to leave academia.
Yeah.
I'm going to go into industry. How would I evaluate a company and an opportunity?
Ooh, yeah, and that's a tricky one, isn't it? Yeah. And again, I mean, I guess my advice would be to talk to a couple of people at that company to try to
Hmm.
find out what the work environment is like, right? Um, One of the things that you'll find if you're moving from a postdoc or a teaching position or a PhD to the corporate world is that the just whole experience of work changes dramatically. And there is a lot of variation in corporate America in terms of what your day to day looks like, how the teams interact, how people treat each other. And this experience will really inform your success or harm it, unfortunately, in some cases. Like you need to find an environment that you can be successful in.
Yeah, I mean, what was that transition like for you?
Um, it was it was interesting. It was a bit tumultuous sometimes, to be perfectly frank. But I also, had a lot of really great mentors and learned a lot of really great skills in the process. So
Hmm.
yeah,
Yeah. I mean, I've heard the same thing from other academics who have gone into industry. I mean, it's interesting because from the outs, I mean, you and I have almost opposite
Mhm.
backgrounds. Like,
Yeah.
I'm definitely
Oh,
opposing from an academic.
I
I,
mean, we
I
both came from math, but different. Yeah, you got your bachelor's in math. I got my PhD. Like that, there's that overlap. But yeah, in terms of
yeah,
experience, very, very different.
and the perception I would say from industry looking at academia is, oh, that's cool. You guys are in your ivory towers, working on research and are completely unplugged from what goes on in industry. And I mean, is that fair?
It was certainly fair for me, right? Yeah, so I think mostly the math department at the U is focused on like very prestigious pure math type problems, with a handful of exceptions. There are some people in the department who consult in stats in other areas or a bit more connected to industry. But I think as a whole, it's very focused on, yeah, what's going on, what's very prestigious in pure math right now. And so mostly that's academic researchers interacting across various departments trying to solve big problems. So,
Yeah, yeah, and and I guess some things to look out for is, I mean, I've heard academia can be pretty political.
mhm.
Um, so industry can be very political too.
It can
So
absolutely.
that's maybe it's political in different ways. I don't know if you have a perspective on that.
Um, yes, it's definitely political in different ways. I'm trying to think about how to even describe that. I mean, the thing about academia is that there really isn't much for reporting structure, even, right? Like, okay, you have the department chair, but you don't really report to the department chair in the same way that you would report up to a team lead at a company. In your teaching responsibilities, you'll have someone who's responsible for teaching overall, but otherwise, you're given pretty free hand to design your classes as long as you're doing well. No one is necessarily going to dig into the details of what you're doing day to day. And so you've said before, what were you saying? There are no bad jobs, just bad bosses or something like that. I think that's kind of a platitude that's actually very, very correct. You typically are going to be reporting to someone day to day in a company. That's a big shift, even from maybe the PhD thesis advisor relationship. And so you just need to find someone you can work well with, especially on their first job where you're kind of adapting to the way things work in the academic world.
Makes a lot of sense. And I would say too, things I've observed from interviewing like PhD candidates, for example, is uh, I think there's this recognition or there's this belief that like I've done a PhD, I'm smart as hell.
Yeah, yeah,
You should hire me, right?
yeah,
And I guess I usually push back and say, well, that's really cool that you're smart. What experience do you have?
yeah. That's just it.
So,
Yeah,
um, and so I would say that some of the things you'd want to do is, be able to talk about your experience and how, and also talk about ways that you can help the hiring manager out. If I'm interviewing you for a job, don't just talk about how you're really awesome at doing math. I really don't care actually,
mhm.
because I want to know like what's in it for me.
Right.
And that's almost hiring managers are. Like you think you're just if you go into a talking about super technical stuff, um, uh, eyes will glaze over, and people will sort of think that you're showing off a bit.
Mhm.
So,
They
keep
won't
that in
care.
mind.
They're not going to be impressed.
No, no. I mean, I may have an understanding of what you're doing. Probably not, actually. There's a very good chance that somebody else will definitely not understand what you're trying to talk about. And so, you want to make sure you're not intimidating the person you're interviewing with. Get to the point. Understand the company you're trying to interview with too, and understand what they do. It's shocking how many candidates don't even understand what a potential employer does or who the team is. All these things are easily researched on the internet today. Um, Look at things like Glassdoor ratings too. I know that might be a controversial piece of advice because everyone who posts negative reviews on Glassdoor has an axe to grind. However, I do know from experience that Glassdoor ratings tend to be a very good mirror into the problems that exist at companies.
That's
So yeah, and again, just you got to sell yourself. Just because you earned your PhD and worked in academia, you're entering a different universe. It's the universe of industry. It's the universe of dollars and cents, and the traditional rules of academia. And you'll know well more about this than I do, Matt. But they certainly don't they don't apply as much.
No, absolutely not. The other thing and I talk about this a lot. You want to find two things if possible, and these might come in sequence. They might happen simultaneously, but the first thing you need is a coach. And a coach is not necessarily exactly the same as a teacher. They're not there to get up and lecture you on some topic in data science. Rather, they're there so you can ask them questions and get feedback on your career path and on the things you're trying to learn. And you can say, hey, I don't get this particular concept in deep learning. Where do you think I can go to understand that? Or I don't understand this thing. How important do you think it is? Or what do you think I should be studying next? This is the career path I'd like to have. What's your advice? Or can you refer me to someone in this area? That's what your coach is going to be. They're there to help you out. And it's not fair, but part of what your academic degree gives you is social capital. With that advanced degree, to be quite frank, you're going to find it easier to get help from people than you would without the degree. Like all privilege, my attitude about privilege is that the best way to make the world more fair is to use that privilege and then use it to help someone else. So get some coaching with someone if possible, and then try to help other people who are developing into the field in the future.
How would somebody find a coach?
That's a good question. I think a lot of it is that there is this strong affinity between people who have done the same studies, right? And so if you can find someone else who comes from your same discipline, who moved into the tech industry, and there are a lot of academics in the tech industry, so they're out there, and just have a conversation with them, that's a good start. And I don't know, but my experience has been that people do like to help each other out, especially when they see that affinity and they're like, oh, you studied representation theory, so did I. You're trying to get into the tech industry. Let me give you some advice that would have really helped me. And it's that whole pay it forward concept, right? Like people are like, oh yeah, had I known this when I was starting out in the field, it would have made a huge difference. Let me give you the same advice. And let me get your take on finding a coach as well, because again, our backgrounds are different, but I think the concept applies whether you're coming from academia or not.
Yeah, I mean, I guess coach, is there a difference between coaching and mentoring?
Uh, Possibly. I haven't really
Yeah.
defined it that carefully. So
I mean, I've always had, mentor relationships either with somebody or being mentored by somebody. I've consciously sought these out because I feel that without somebody to guide you through a lot of like the landmines in a
Mhm.
in a career field or in the industry, and if you're not reading a lot, which is the other thing I would say is like read a ton.
Yeah,
I know you and I do all the time. Stay current, but like you're not going to know everything.
never.
And
No.
so there needs somebody to bounce ideas off of. I think also you need somebody who can help make introductions. Like you have a
Mhm.
cold start problem and nobody knows you. And as we're always fond of saying, like in most situations, the enemy isn't so much competition or the economy or anything else. It's like obscurity is your number one problem.
Yeah.
Nobody knows you.
And the lack of experience, right? It's a chicken and egg
Hmm.
problem. You
Yep,
never had a job, so no one ever wants to give you a job, basically. And you need
exactly.
someone to help you get past that hurdle. Yeah.
Hmm. Yeah, exactly. And so by getting a coach or a mentor, that'll help short circuit.
Right.
Um, I think a lot of your progression, and that's a good
Mhm.
investment. Like you say, people want to pay it forward. I mean, there's obviously some people out there that don't, and they're really selfish with their time, and that's kind of how that is. And that's also a reality. Is some people don't want to mentor people and whatever. Um, but I mean, there's an old salesman, Zig Ziglar, actually, who I think is fond of saying like, you can get where you want by helping other people get where they want. And so
Yeah.
that's sort of this golden rule of the universe. And when I first heard it, I thought it was kind of corny. Like it's just this like cheesy platitude that,
Right.
of course some sales guy would say, but if you start ruminating on that for a few years and you're like, yeah, that actually makes a ton of sense. I think that's why you and I are pretty, in a lot of cases, pretty selfless with our time with people. Within reason, we're not going to
Right.
spend a lot of
Really.
time with people that aren't interested in. But if you do get a mentor, you were talking about this the other day on that data science office hours too, but or happy hours or whatever it is. But like if you get a mentor, take that relationship seriously. Uh, Pay attention to the advice and act on the advice. And um, I think that makes the person doing the mentorship feel good. And it'll also give you a chance to try out some new stuff.
Yeah.
But at the end of the day, what's up?
Oh, I was just going to say, here's something very concrete, which relates to, I mean, I think we've all both participated in organizing meetups, but frankly, you've done a lot more of that than I have. But if someone comes to you and finds out a topic that the meetup is interested, like SLC Python, like, hey, I want to talk about, well, people want to know about Prefect, which is a data orchestration system. If I then go and learn all about Prefect and give a talk on that,
That's
you're going to
cool.
be super grateful. And the reality is that by giving that talk, you'll probably find multiple people who are interested in being your mentor or your
Oh yeah.
coach.
Oh yeah. Yeah. Meetups. I forgot to mention that. Yeah. There's lots of local groups. I mean, even in the age of COVID, there's still, um, I
Or
would
not local.
say, or non-local too. I mean, there's a ton of great groups out there, and yeah, that's a great area. Yeah, thanks for pointing that out because you can meet people in the field who are doing stuff, whatever stuff is. You can giving a talk will boost your cred a ton within that peer group, and it's funny how that feeds on itself too.
Yeah.
As you're seen as being more authoritative, suddenly you're seen as being more authoritative, and guess what follows from that? Job opportunities,
Yeah.
right?
The
So,
other thing about that is that as an academic, you're actually playing to your strengths, right?
mhm,
Because, well, what do you have to do as a PhD student? You have to research things. So, and it's stuff that you don't know, and your thesis advisor might not know. They'll say, "Oh, I think you should go look at this paper. It's new in this area. I don't really know what they're doing. Some combination of algebraic geometry with something. Go read it, see what you can figure out." You get good at that skill if you're getting a PhD in math or some other mathematical area. And second, giving talks. I mean, you generally are required to teach during your PhD or master's degree, and you're also generally required to present conference talks, seminar talks. So yeah, this plays to all of your strengths, and whoever's organizing the meetup will be very grateful. So will the audience, because you're
mhm.
teaching them about something new that they don't have time to learn.
Exactly. And the audience is I can't speak for all meetups, but I know the ones that we do, it's comprised of people who hire, right?
Yeah,
So,
or
you
no
know,
people buyer. They'll be like
exactly.
a
Yeah. I
job
mean,
need
suddenly
recruit.
you have one degree of like Kevin Bacon from like a hiring manager
Yeah,
versus, however many you are if you're not, right? So, but it's one of those things where, your success is going to largely be dependent upon like how much energy you put in. Again, because you have a cold start problem, right? Unless somebody's going to make an intro, or unless you're doing such awesome research, um, or stuff in academia that the Facebooks and Googles of the world are going to scoop you up. Which, if that's you, then awesome. Like,
that generally means you're in computer science, probably not pure math. Once in a while, but usually that's going to be a computer science person that has that experience.
right. So, but yeah, I mean, but again, to maintain your career, I mean, you're going to be expected to put yourself out there. So I guess, if we were to summarize our advice, I guess, looping back to the beginning of the discussion to the end, like what would we, advise
But
people to
actually,
do?
let me cover one more topic
Yeah,
too. So
go
I
for it.
talked
Yeah,
about
sorry.
coaching. The other thing that's important, and this goes back to what you were talking about as a hiring manager, you want to get out of the idea that they're really hiring you to do a job. Instead, you want to reframe it that they're going to sponsor you. And basically, you are going to go to them, apply to a job that you're underqualified for, and say, hey, I don't really know what I'm doing. I've studied Python, I've studied TensorFlow, PyTorch, whatever. I've gone to these meetups, but I haven't had a data science job. So be humble, go into it explaining your situation, but say, but I have this PhD in chemical engineering or something that's very mathematical. I can think logically, I can communicate, and I can learn. And I'm looking for someone like you to be willing to take a chance on me where I can be making hopefully significant contributions in 6 months. And also don't assume that you're going to get a full data scientist or ML engineer's wage in your first job. You basically offer to work for cheaper, even though it's unpleasant, with the assumption that you'll learn on the job, you'll become more valuable. Either that company gives you a raise, or after a year, you can go somewhere else where your wages are commensurate with your skill set that you've gained. But yeah, treat it as a sponsorship, and don't come in acting like you know data science, because you don't. No matter what books you've read or what blog posts you've worked through, you really don't know much about the experience day to day of being a data scientist in the business world, and you need some help, and you want to frame yourself that way.
Yeah, it's good advice. Cool. So in summary,
It's a lot of stuff.
there's a lot of stuff. I look at the clock and like, oh, well. talked a bit about this, but it's a key topic though. It's something we see every week, in the various meetups and forums and talks that we're in. This always comes up. There's a lot of bright people out there that want to get into data. And, to recap, languages, know how to program, pick your poison, Python, R. SQL is a great one to know too.
Probably before the others, even frankly. I think we may or may not agree with that, but I would almost say that.
I disagree with that a bit, but I think we agree to disagree because ultimately you're going to have to know it anyway. I wouldn't say you have to know it, but it's going to make you a better practitioner.
Absolutely.
But I would say though, if you're doing machine learning on or deep learning on like images, how much SQL do you need to know?
Oh, that's a good point.
Right.
The problem I have maybe, and we should look at the stats on this, but my impression is that there are more data science jobs on event data, business data than there are on images. And images are a very niche area. It's true. I mean, if you're a really great machine learning researcher coming out of a CS PhD and you get hired by Google just to work on image problems, you'll probably never touch a database.
Yeah.
That's rare.
Yeah. So the languages piece, understand the path that everything is going in the field right now too. That's another big piece. The world of data science is a different world than it was even 2-3 years ago. So just understand, as a Gretzky quote, Wayne Gretzky is, famous for saying, skate to where the puck is going, not where the puck is. And finally, find mentorship and a good company that is going to make a difference for you. And you can make a difference at too.
That's right. Yeah. And in particular, probably focus on that, even if you come at a very low level, over getting like an additional master's degree beyond your existing degree. Because I think it's just a better use of your time to try to actually find a job, even if it's very entry level, as long as there's a path for you to develop and grow within that job. It's going to be a better education for you, given that you already have the really sound mathematics foundation from your degree.
Mm-hmm. Yeah. So anything else you want to add to this?
I think that's about it.
Okay. I'm sure we can keep talking about this, and there's a good possibility we may have a follow-on talk on this, or maybe we can interview some
that's a good idea.
some of your peers. That might be a cool one too. Well, as always, thanks for the Monday morning data chat. To the audience, if you like the material in the Monday morning data chats or any of the other videos we put out, please like and subscribe to our YouTube channel. Definitely appreciate it. And Matt, we'll see you next Monday. Take care, man.
Talk to you soon.